Here are the solutions to the special right triangles worksheet. As with any assignment I give you guys, please make sure you are looking at the videos of notes before you start any of these. I know from the Pythagorean theorems worksheet some of you still had questions, but I did one of every type in the notes. So again, it's in your best interest, even though I know for the most part this is review, but it's been a couple years from geometry. So please make sure you're also watching the notes I post as a video or a PDF. All right, so for 1 through 12, there was a mixture of the two special types of right triangles. It was either a 30, 60, 90 or a 45, 45, 90. Keep in mind, when it is a 30, 60, 90 triangle, the short leg is x. It could be any number. And then to get to the longer leg, it's going to be x times radical 3. And then to get to the hypotenuse, you take your short side and just double it. So again, those are the lengths of the sides, the ratios for a 30, 60, 90 triangle. When we're looking at a 45, 45, 90, both legs are the same. And then the length of the hypotenuse is going to be one of the legs times radical 2. All right, so for number 1, and again, you can always check when you're done by evaluating the sides into the Pythagorean theorem and just see that the two sides of the equation rather come out to be the same. All right, so we're given the hypotenuse here. So to go backwards, the short side, to get to the hypotenuse, we always double it. So to go backwards, the short side A is going to be half the hypotenuse. So that means A is 40. And then to get to the long leg, we take the short leg and multiply it by radical 3. So side B is just 40 radical 3. And knowing that we're looking at a special right triangle allows us to answer the sides here in a much quicker way than always using the Pythagorean theorem, especially when more than one side is missing, which it is here. But now that we have all three sides, you could check by substituting everything in. So just real quick, we could show 40 squared plus 40 radical 3 squared should equal 80 squared. So this will give me 1600. I'll just break this apart here. So 40 squared will give me 1600. Radical 3 squared will just give me 3. And then 80 squared will give me 6400. So now this is 1600 plus 4800 equals 6400. And then the two values over there do add up to 6400. So I'm not going to check for everyone, but that is a way you could check when you're done. All right, very similar in number 2. We're given the length of the hypotenuse here is 62, so I go straight to the short leg. I never use the hypotenuse to go straight to the long leg or vice versa. We always kind of go to the middle man here and go to the short leg. So that means the short leg is half of 62, which would make this 31. And then the length of the longer leg is going to be the short leg, 31 times radical 3. Now for number 3, notice this is 45, so this is a 45, 45, 90 triangle, which means both legs are going to be the same. So F also has a length of 25. Now to get to the hypotenuse of a 45, 45, 90, I take one of the legs and multiply it by radical 2. So I get 25 radical 2. Likewise for number 4, this is a 45, 45, 90. Again, all we need is one of the angles here. We would just know that the other one would be 45 because all three have to add up to 180. So the two legs are going to be the same length, so H is 17, and G, the hypotenuse, is going to be one of the legs, 17 times radical 2. And again, you could check if you take 17 squared plus 17 squared should equal 17 radical 2 squared. So you could calculate that as well. All right, for number 5, now we're given the longer leg, so K is the 17 radical 3. Again, I want to go back to the short leg. All I have to do to go from the long leg to the short leg is divide by radical 3. So if I took 17 radical 3 and divided by radical 3, I'm just left with 17. So it's nice when the long leg has the radical 3 with it. To go back to the short leg, we simply just remove the radical 3. So I is going to be 17, and then to go to the hypotenuse, we just double that. So J is 34. Likewise for number 6, P is 21 radical 3, so the short leg is just going to be the 21, and then we double that to get 42 for the hypotenuse. All right, now number 7, this is a 45, 45, 90 triangle. So both legs, even though they're missing, they're going to be the same. So I take the hypotenuse and I'm going to divide it by radical 2, because to go from the leg to the hypotenuse, we multiply by radical 2, so we have to go backwards. And then I want to simplify this, so I'm going to multiply top and bottom by radical 2. So I get 8 radical 2 over 2, which is 4 radical 2. So each leg, R and Q, are 4 radical 2. And again, you could check this if you took quantity 4 radical 2 squared plus the quantity 4 radical 2 squared. It should give you 64, and the square root of that would give you 8. All right, likewise for number 8, the hypotenuse of a 45, 45, 90 triangle is given to us. I'm going to take that 12, divide by radical 2, and I need to rationalize. So this will give me 12 radical 2 over 2. Now, you don't always have to show this step. If you notice with what we did in 7 here, 8 over radical 2 will turn into 8 radical 2 over 2. Notice when we took 12 and divided by radical 2, it became 12 radical 2 over 2. So if you catch on to that, by all means, you can use that as a way to get to the answer a lot quicker. So then this just becomes 6 radical 2 for T and S. Also, if you took 6 radical 2 and multiplied it by radical 2, that would give you the 12. So that's also another way to check. All right, looking at number 9, we're given the short leg or the long leg, but in this case, the long leg does not have the radical 3 with it. So just like we were doing with 7 and 8, we're going to take that 6 and divide it by radical 3 to get the short leg. And then we need to rationalize. So here we're going to get 6 radical 3 over 3, which is equal to 2 radical 3. So our short leg is 2 radical 3. Then I need to double that. So when I double the 2 radical 3, I'm just multiplying the outside 2 by the other 2. So to double 2 radical 3, I'll put the 2 in front here. 2 times 2 radical 3. I just multiply the 2's together, so I get a 4 radical 3 for the length of the hypotenuse. Likewise for number 10, I'm going to take the 12 divided by radical 3, rationalize. So we end up with 12 radical 3 over 3, which becomes 4 radical 3. So my short leg is 4 radical 3. Now if I double that, I'm really just doubling the 4. So the length of my hypotenuse is 8 radical 3. All right, looking at 11 and 12, they're both very similar. A is 4 radical 2, which makes B also 4 radical 2. If you notice, this kind of turns out now, if you go back to number 7, both legs were 4 radical 2. So to get the hypotenuse, I'm going to take 4 radical 2 and multiply it by radical 2 here. So this becomes 4 times 2. So C just has a length of 8, which matches the 8 up here in 7. So those were identical triangles. Now for 12, D is 7 radical 2. So is E 7 radical 2. So now if I took 7 radical 2 and multiplied it by radical 2, I'd get 7 times 2, which is 14 for side F, or the hypotenuse. And we saw that, what problem was that? I might be thinking of another problem here. All right, so for 1 through 12, we were just using the ratios that I had mentioned at the very top here of the 45, 45, 90, the 30, 60, 90. As always, guys, please let me know if you have any questions. All right, for the last 4, we had to draw pictures. And I will tell you, 13 and 14 were pretty much the same, just different sides were given. So we didn't have to do anything different between 13 and 14, and then 15 and 16 were very similar. But what we want to do for 13 is just go ahead and draw a square, and then draw a diagonal in here. So the properties of a square, all 4 angles are 90-degree angles, right angles. Now if we draw a diagonal in here, it's going to cut the 90-degree angles that it intersects in half. So now we have, it doesn't matter which triangle we look at here, we have a 45, 45, 90 triangle, because both sides of a square are going to have the same length. So for 13, it's just saying what happens if each side is 10 centimeters, and we can answer this very quickly. The hypotenuse, which is our diagonal right here, is going to be 10 times radical 2 centimeters. So we can answer that very quickly. Same thing for 14. If we were to make this picture, and again draw on a diagonal, but now the lengths of the sides still going to make, I'll go to the top. So if we're looking here, we can have a 45, 45, but now each side length or leg is going to be 13. That makes the diagonal, which is the hypotenuse here, is going to be 13 radical 2 centimeters. I didn't label the other problems because that wasn't given to us, but whenever you're given a length here, please include it. All right, now looking at 15, we have an equilateral triangle, and altitude is the same thing as a height. So remember, like if you're in a plane and your altitude's increasing, that's just the height, how high up you are from the ground. So we're going to go ahead and draw an equilateral triangle. That means all three angles, all three sides have the same length. This is one that I actually did an example of in the notes as well. So what's happening here is the altitude is going to cut this angle at the top in half. And if all three angles are the same, we know that this is going to be a 60 degree. This is our right angle, and then up here is going to be 30 degrees. And then we have each side is 18, so this is 18. It's going to cut this side in half, so right from here to here is going to be 9. And then we want to know what the height is, so we're asked to find the altitude here, which that's the longer leg. So the altitude is simply going to be the short leg 9 times radical 3 inches. And we'll do the same for 16. All right, so our altitude, straight down. So we know each side length here is 24. So it's going to make the short leg, or the short side right here, because here's our right angle. This is 60 degrees, this is 30 degrees. So it's going to make this half 12, and then the altitude here, which is the long leg, is going to equal 12 radical 3 inches. So those are the solutions to the special right triangles worksheet. Hopefully, after watching this, a lot of your questions could have been answered, but please let me know if you have any others.